Our discussion today will be on descriptive statistics and what we call displaying of descriptive statistics. This is yet another important topic in quantitative methods, where we will learn how to present data in different types of pictograms. So as statisticians, we must be able to understand what frequency distribution tables are, learn what we call histograms. Histograms are joined bars like this. We'll learn how to draw bar charts, which are disjoint bars, which look like this. We also have what we call pie charts, which looks something like this. We also have what we call cumulative frequency graphs. They always accumulate, they don't fall. In this cumulative frequency, you can identify the quartiles. A quartile is a quarter. Q1 is a quarter, or 25%. Q2 is 2 quarters, or 50%, which is half. And Q3 is 3 quarters, or 75%. So this can be attained from what we call a cumulative frequency graph. We also have a shape which looks like this. This is called a box and whisker plot. It is important to identify what are called outliers. And these outliers are simply data that is outside a particular data set. All right, so we're going to start with what is called ungrouped data. Ungrouped data is simply data that is put in a disorganized way. They're not arranged. For instance, we have 0, 3, 0, 1, 0, 4, 0, 4, 11, 18, 10, 12, 15, 10, 20, 22, 21, 24, 30, 2, and we have 21, 30, 50, 51, and 80, let's say 90. So if you're given data which is scattered like this is called ungrouped data. So I'm going to teach you how to draw what is called a stem and leaf diagram. So stem and leaf diagram will help you arrange the data in a particular order. So we call this a stem and we call this a leaf. So we will discover that the numbers that we have, the smallest starts with a 0, and we have 10s, 20s, 30s, 40s, 50s, 60s, 70s, 80s, and 90s. So on the zeros, the smallest number is 0, 1. So 0, 1, we arrange them in order, and you say ascending. The next number is 0, what? 0, 3. 0, 3. The next number is 0, 4. 0, 4. And we have another 0, 4. 0, 4. On the zeros, we are done. On the ones, we have the smallest number is what? 10. So 1, 0. Help me. What's the next number we have? 11. So 1, 1. What's the next number we have?
1, 3.
1, 3.
No, 1.
1, 2. It's 12, in fact. Then 1, 3. Then 1, 5. On the 20s, what's the smallest number we have? 2, 0. Then 21. Then 22. then 24. We're done with the 20s, right? Then the 30s, we have what? 30.
30.
Then 31.
31.
Then 31.
50.
32. Then 40, there's nothing. 50s, 50. And what? 51. 60s, there's nothing. 70s, there's nothing. 80s, there's nothing. 90s, we have what? 90.
90.
So lesson number 1, where we don't have figures, we can put the numbers as they are, but don't put anything in there. Don't put a 0 there. It will make it 4. So you'll list the numbers from the smallest to the biggest, but where there's nothing, just leave it as it is. Are we together? Then we are asked to calculate the range. The range is simply the difference between the highest number and the smallest number. So the maximum value of n and the minimum value of x. So what is our range in this case? Highest number is 90. The smallest number is what? 0.3. So the range is the difference between the highest number and the smallest number. So we have 87.
Collins, wouldn't it be 0.1?
Actually, 0.1. Yes. Smallest number is 0.1. Thank you. So we have what? 89. Are we together so far?
Collins,
Yes, sir.
on the 10, we have 2 10s, not 1. So there on the ones, we need to have another 0.
Okay, great. So there are 2 10s. There's this 10 and the other 10. All right. So why didn't you identify it earlier? So please, on the ones, we have 2 10s. So I'll add where there's 1 there is 0. 1, 2, 3, 5. 5. So have it like this. All right. Then mod. So I'm starting from what you guys know to what you don't know. How do you find the mod? What does mod stand for? The most frequent.
Collins, still you haven't changed.
Supposed to be 0 here, yes.
And the 1.
And the 1.
Yeah. 2 zeros and 1, 2, 3.
And 1. 2
5.
zeros and 1.
2, 3 and 5.
3 and 5. Okay. So the n 1, 2, 3, 4. 1, 2, 3, 4, 5. So 4 times 5 is 20. Let's ensure that the n is 20. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20, that's where we are. All right. So what is a mod?
Four and 10.
So what is the mod? The mod is the most frequent. So which numbers are the most frequent here?
10 and 4. And 14.
So,
yeah, 10 and 4. Yeah.
the ones that are recurring, there's 10, there's 4. All right. So 0, 4, and 10. So 4 and 10. These ones are our most frequent values. So that's how we find our mod. Then we go to the quartiles. I said quartile 1. We have 3 quartiles. There's quartile 1, there's quartile 2, and quartile 3. So what is quartile 1? A quarter of n. And our n is 20. So the rule here is simply that when we find a whole number, we get that number and the next number and divide by 2. So a quarter of 20 is 5. So we're getting the 5th position plus the 60th position. We divide by what? By 2. Then Q2 is half of n. Our n in this case is 20. So half of 20, we're going to get 10. What does this mean? Anyone? Which two numbers are we considering?
The 10th position and the 11th position.
10th position and the 11th position, you divide by 2. Take note that other books will ask you to put n plus 1 is still the same directly. N plus 1, but the rule slightly changes. But whatever rule you get, you need to understand the underlying principles. So 3/4 of n, here we're going to have 3 over 4. Our n is what? 20. So here we're going to get 15. So what does it mean? The 15th and the what? And the 16th, we divide by what? By 2. So in this case here, the first one was what? The 60th, the 5th and the 60th. So the 5th and 60th, let's look for the 5th and 60th. 1, 2, 3, 4, 5, 6. So this is 10 and 10. Whenever the number is just the same, you maintain the number because averaging it gets back to the actual number. So we have 10, which is our what? Our first quartile. First quartile is the 25th percentile. Then the next one, we found 10 and 11, the 10th and the 11th. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what two numbers are these? What two numbers are these?
15 and 20.
15 and 20. We agree? So what's the average of 15 and 20? About half of 25. 35, what do we get?
17.5.
17.5. All right. Then 16th and the 15th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is 30 and 31. So 30 plus 31, averaging it, we're going to get what? 30.5. So this is how we find the quartiles. So this will take us to calculating what we call the interquartile range, which is simply the difference between quartile 3 and quartile 1. So the third quartile is 30.5 and the first quartile was 10. So the difference here is 20.5. So this is called the interquartile range. The interquartile range. So when we have the interquartile range, what we get is called the semi-quartile deviation or semi-quartile range if you want. So half of the 20.5, we're going to get 10.25. So this 10.25 is called the semi-quartile deviation. It's half of the interquartile range. Now, having found these important constituents of descriptive information, it will now take us to understanding how to come up with this polygon, which I said is important in statistics. It has 5 key parameters: the minimum value of x and the maximum value of x, the first quartile, the second quartile, and the third quartile. So we found the first quartile, second quartile, and the third as 10, 17, and 30, 10, 17.5, and 30.5. So 10, 17.5, and 20.5. Is it 30.5? So in this information that we have, you can find the differences between these quartiles. The one with the larger difference here tells you where the bias is in terms of the skewness. So 17 minus 10, here we're getting a 7.5. 17.5 from 30.5, here we're going to get a what? 13. So already there's a bigger gap here. So we can say this is skewed to the right because the gap here is bigger. So we can say it is skewed to the right. The other information that I said is important to get from the data is the highest data and the smallest data set from here. So 0, 1 is the smallest data and the highest data set is 90. So this is what we put here, 1 and 90. So we also calculated our interquartile range, which was the difference between what? The highest number and the smallest number. So 10 from 30.5 to be 20.5. Now, there's a special term which we call the correction term. When we multiply 1.5 to the 20.5, we get what we call the correction term. Please take note that I have spoken of a lot of important things here. I'm deliberately starting with the simplest topic for the beginners of what you think you know. And I'm sure from what I'm explaining, there's a lot that you are learning. So this is called our correction term, 30.75. So you add it here and you subtract it here. So 30.75, when you add a 30.5 there, we're going to get 61.25. It's like you're putting a ruler here, you're closing up. Anything above the 61.25 is an outlier. So if we're going to check, 90 is outside the box, so it's an outlier. Then from the 10, we subtract 30.75. So we're going to get negative 20.75. So meaning this one has survived. It's inside. It's like we're placing a rule. We'll see which numbers will be outside this range. So unfortunately, 90 is out of range, and we can confirm if there are any other figures out of range here besides the 90. Is 50 out of range? Let's see. Extreme maximum value is 61.25. So 50 is also inside. So 50 has survived. So the only outlier that we have here is our what? Our 90. So I now need you to apply what I've talked about to the first test that some of you may have. So let's look at this quiz test that your friends wrote. So we're being asked to come up with a stem and leaf diagram. So Blake wants to create a stem and leaf diagram. So there's a team points that have been given here, 90, 87. So which one of the following is true? Which one represents a true stem and leaf diagram? So what's our highest figure there? And there's the lowest figure. The lowest figure here is what? 40. And the highest figure here is what? 99. So we have 4, 5, 6, 7, 8, 9. Regardless of whether we have any 60s or 40s, we need to list them down. So let's go to the 40s. The smallest is 40 and 49. All right, so this the arrangement is okay. Then we go to the 50s. So 50s, we have what? 53, which is there. 55, and another 55. So this one is out because it only gives us what? 155. So maybe this guy stands a chance. So this one is correct. Then we go to the 60s. Do we have any 60s? There's a 60. So here there's supposed to be a 0. So here this is wrong because there's no 0. This is wrong also because there's no 0. All right. There's supposed to be a 0. So maybe this guy stands a chance. There's a 0 here. And this one has no 0. So already, even before you go any further, you'll be sure that this guy has qualified. Then the rest are obvious. We go to 76, which is here. 79, which is here. When you go to 85, 85, which is here, and 87. Then we go to 91 and 99. So this is how a stem and leaf diagram is supposed to be drawn. Are we together? Are we following?
Yes, we are following.
All right. Then
Yes.
takes us to another important polygon, which is called frequency distribution table. Frequency distribution table has its own important format. We have class, we have the frequency there, and we have the cumulative frequency. So for instance, we would have 1 to 5. Or let me start from 0 to 5, 5, 10, 15. We have 10, 15, 20. Then here we have 4, 3, 4, 7, 3, 4, 7, 6, 3. So let me explain important things about the class. The class can give you two important parameters. Firstly, to identify the height, you always use any boundary. From here to here, use a vertical boundary. So our height is a 5 because it is the difference from here to here, from here to here. All right. Then secondly, if these ones in the diagonals are the same, you can also subtract this number in that to give you 5. Make sure that these diagonals are the same for you to produce a histogram. So this is our frequency. And to get the cumulative frequency, we add on. So the 4 comes here, we add it to the 7, we get what? 11. We add it to the 6, we get what? 17. We add it to the 3, we get 20. This 20 is also automatically the total here, which is our total of the frequency. We have a 20. So now, when you're dealing with a relative frequency, relative means out of the total. So relative frequency, and we also have relative cumulative frequency. So to find the relative frequency, we just total out of. So this is 4 out of 20. What is 4 out of 20? 0.2. 7 out of 20, 0.35. 6 out of 20, 0.3. Then 3 out of 20, 0.15. The total here is 1. Now, this relative frequency is also called the probability of X sometimes. It's the same thing. Then, like we did on the other side, we add on. The 0.2 comes here, we add to this, we get 0.55. The 0.55, we add the 0.3, we get 0.85. 0.85, we add 0.15, we get 1.0. This 1.0 is the same as this. So this is what we call the frequency distribution table. Frequency distribution table. Now, sometimes when you're given ungrouped data, you need to really look at the figures that are found in that space that is being discovered. So for instance, here, if you want to discover your classes, you can say between 0 and 10, between 10 and 20, between 30 and 40, between 50 and 60, (20 to 30, 30 to 40, it goes on and on. So how many are there between 0 and 10? There are 1, 2, 3. So your frequency here is what? 3. Between 10 and 20, how many are there? 1, 2, 3, 4, 5, 6. We put 6 there. Between 20 and 30, how many do we have? 1, 2, 3, 4. 4. Between 30 and 40, we have 1, 2, 3. You go on and on. Between 40 and 50 is 0. 50 and 60 is 2. 60 to 70 is 0, 0, 0. 90 to 100 is 1. So this is how you can get data from an ungrouped specimen.
Collins,
Uh-huh.
sorry, I just want to see the frequency distribution table.
The frequency we are from looking at,
Yes.
this one.
Okay. Relative cumulative frequency 0.2 plus 0.35
Mm-hmm.
is 0.55.
0.55, yes. 20% plus 35% is 55%. 55% plus 30% at 5%. 5% plus 50% is 100%.
Let me
Just confirm it.
Okay, all right. Okay.
Right.
I think it's you missed it. Okay.
So now you'll be given in a quiz, especially for some of you. And a quiz comes like this. You've been given a 6-page manuscript and you are being asked to analyze
Collins,
data into intervals of 5.
just a minute, Collins, sorry. Let me drag you a bit to the previous slide, 2 slides, I think, before this one. No, move it forward. Yeah, no, the next one. Again?
Again?
Yes. And again?
This is the last one.
No, before this. Okay, keep
Oh,
on
yeah.
moving. I'll tell you. Again? Again?
That's all. That's the first one.
Yeah, this one.
Mm-hmm.
No.
This one.
Yeah, this one.
Mm-hmm.
Yes, on the class and the frequency.
Mm-hmm. So here, this is 0 to 9, in fact. All these are zeros. And this is 10 to 19, except that here we're using a histogram. We just add 10, but we don't add any 10th number. All right?
Yeah.
Yes, 10 to 20, but here we know that's 10 to 19. 20 to 29, but we put 30 there, so that this becomes like a histogram.
Actually, my question was on the frequency.
Mm-hmm. So here,
just go through the frequency.
1, 2, 3, 4. So this is there 4 there. 1, 2, 3, 4, 5, 6 there, 6 there. 1, 2, 3, 4, there, 4 there. 1, 2, 3,
Okay.
3 there. Just count them as they are.
So the first one, okay, yeah.
This one
So
is
I
4.
thought it's 4.
Yes, 4, not
The
3.
first one is 4.
Not 3, yeah. 1, 2,
Not
3.
3.
I'd put 3
Right.
initially, I think.
Yeah.
All right.
Okay. Thank you.
Great. So when you're going to group data, I need you to understand that these questions now are coming from what I've just explained. So they group the data in intervals of 5. Okay, then they ask you to fill in. So between 20 and 26, how many are they? So we're going to say 20 to 26, 24 to 26. So we have what? 1, 2. Why are we not adding the 26 here and this other 26? Because it's falling in the hour, you know? You need to be very careful. So here we're going to pick only 2. In our mind, it is 24 to 25. The 26 will be in the, because we're going to consider 26 here, it also fall in there, it will intersect. Then here it's 26 to 28, but we're actually looking at 26 to 27. So here we have 1, 2, 3, 4, 5, 6, 7, 8. That's where the 8 is coming from. 28 to 30, but in fact it's 28 to 27. 28 to 29. We have 1, 2, 3, 4. Where the 4 is coming from. Then 30 to 31. 30, 31. So 1, 2. This is a 2. So how do we get the 0.125? We first added the total here. So this is 10 plus 6 is 16. So 2 over 16, we get this. All right. Then 8 over 16, we get this. 4 over 16, we get this. 2 over 16, we get this. The cumulative frequency, the 2 comes there. 2 plus 8, 10. 10 plus 4, 14. 14 plus 2, 16. So this is how the cumulative frequency, the frequency distribution table looks like. Just in tandem with what I'm explaining. Are we following? Are we moving together? All right.
Collins,
Yes, sir.
just to ask, will they ever ask any other number other than 5 for the intervals? Or it's always just a standard?
No. They ask, there are many. It could be like here. The interval here is not even 5.
No.
It's actually 2. The class interval
Yeah.
is 2.
Yes.
All right.
Yes.
So this was just an error in the question. So this is actually 2.
Okay.
So
That's fine. Yeah.
don't follow this difference in here. Yeah, it's only correct because these answers are the same. These diagrams are the same, but it's safer to move direction like that. All right, so we proceed. How do we compute the measures of dispersion? So if you are given figures like 1, 1, 2, 2, 1, 2, 2, and 5. All right. So let's calculate our mean, the variance. So we square this. So 1 squared is 1, 2 squared, 4, 2 squared, 4, 5 squared is 25. So let's total up here. This is called the summation of x. This is called the summation of x squared. All right. So what is the total here? 10. What is the total here?
34.
So the mean is called x bar. It is given by the formula summation of x over n. So n, we have 1, 2, 3, 4. The number of observations are 4. So to find our mean, it is summation of x, which is 10 divided by 4. We get 2.4, 2.5. Then variance is given by summation of x squared minus summation of x to the power 2 over n, everything over n minus 1. So here we have 34 minus 10 squared over 4 divided by 4 minus 1. So you start from this part. 10 squared is 100. 100 divided by 4 is 25. So that 4 minus 25 over 3. So what do we get? Of 9 over 3. So our variance in this case is 3. So to find the standard deviation, we simply square root our variance. So square root of 3 is actually, what's the square root of 3? What's the square root of 3?
Is it 9?
Pardon?
9.
The square root.
Square
What's the
root.
square?
1.73.
1.73 what? Preferably 3 decimal places.
1.732.
1.732. So this is called our standard deviation. All right. So we go to what is called the coefficient of variation, which is given as follows. So to find the coefficient of variation, we simply find the standard deviation over the mean times 100. You can leave it as a percentage or as it is. So it gives you the percentage of dispersion, okay, which is 43.3%. That is how we find our coefficient of variation. Then to find the median, who remembers how to find the median? Median is half of n. Our n was 4. So half of 4 is 2. So what does it mean 2? We get the second number and the third number, we divide by 2. So in this case, the second number and the third number, it's the same value, it's 2. So we pick it. Or if you want, you can show it. 2 plus 2 is 4 divided by 2. We get a 2. So this helps us find what we call the coefficient of skewness. So the coefficient of skewness is given by 3, the mean minus median over standard deviation. So our mean was what? 2.5. Our median was 2, and our standard deviation was 1.732. So here skewness just tells you where it's bending. If you get a 0, it is normally distributed. If you get a positive, it is skewed to the right. If you get a negative, it's skewed to the left. So already there, we know it's a positive figure that we're going to get. So we're going to get 0.86, positive 0.866. So we can tell that this distribution is bending or skewed. Skewed is spelled like this. Skewed to the right. So this is usually used in statistics to approximate the degree of biasness. If you have too many males compared to females and males are on the right, it's skewed to the right. If you have too many females, skewed to the left. The pass mark is such that the 50 is a pass mark and many of you fail, skewed to the left. If many of you pass, skewed to the right, or it's positive. So this is very important. Sometimes you'll be given a lot of data. You need to understand these formulas. So in your test quiz, this is what came through. We are given numbers, and it could be many. They ask you to find the mean. They ask you standard deviation, correct 1 decimal place. So I've taught you what to do. Enter the figures, square them, identify the number, which is 20. Then you use a formula. Right? So we've also spoken about the chart. So we've been given a following chart, and we've been asked identify what chart this is. Is this a bar chart or a histogram? So this is a histogram because it's attached. What is the number of students with the height between 135 to 140? So you go 135 to 140. The frequency here is what? 20. So the height is what? 20. So remember, this is teaching you how to present data in a simple way. Use a graph to represent quantitative. This data is used to present quantitative data. Is it true or false? It is true. This is quantitative data. Which takes us to a theoretical session. What is quantitative and what is qualitative data? Anyone can give examples? Anyone? I taught this already. I can only excuse the beginners, but the rest of you, please don't embarrass me. I explained this. What is quantitative and what is qualitative data? And give me examples where possible. All right.
Mark, can I try?
Uh-huh.
Yeah, basically quantitative data is data that can be presented on that can be quantified. Yeah, that can be numbered, that's presented numerically, but qualitative is data that cannot be presented numerically.
All right. So quantitative data is expressed in numerical terms. It can be measured. It deals with quantities used for statistical analysis, like height, the weight, temperature. Whereas qualitative is non-numeric data, which describes qualities or characteristics. It deals with non-quantifiable data, like the color, the emotion, the types of fruits, and opinions. Examples of quantitative data, which is presented by histogram, is height, like I've mentioned, the weight. Qualitative is the colors of the parking lot. It's red, it's blue. Then we go to nominal data. Nominal data is simply categorical data, which is distinct. All right. For instance, what gender is male or female? That's distinctive. What type of animal are you? Are you a mammal? Are you an amphibian? It can be both. Whereas ordinal has categories. It is in intervals. It makes not very uniform. For instance, what is your tribe? Mbemba, Tonga. It can be both. All right. This is under qualitative data. Under quantitative data, we have two main strands that we need to understand. We have continuous and discrete. So in dealing with discrete data, it is distinctive information, which is countable. For instance, number of cars you have, you can't have 1.5 cars, but 3 cars, 4 cars. How many students are in this class? There are 4 or 5. That's continuous. Is data that has integers, a temperature, that's decimal point, 24.5, 25.1. All right. So you discover that you can relate discrete data to what? To nominal data, and continuous data to ordinal data. So in a nutshell, under quantitative, we have discrete, it is countable. Under qualitative, we have nominal. It is category, it's discrete. Under quantitative, we have continuous. Under qualitative, we have what? Ordinal. So these ones are similar, but on opposite grounds. Are we together? All right.